Okay, well, like I said in the description, I recently was able to get Autodesk Inventor installed on my home computer. Um, for as long as I've been working on the project, in order to do any design work on the Subcontrabassoon, I've had to go to my dad's shop and do it there. But now that I have Inventor on here, um, I can, not only is it more easy to do some modifications, but it also makes it a lot easier to stream that for anyone out there boring enough to actually want to see such things. So let's get this open, and I'll talk a little bit about what work I have to do. Hold on a second. Let me... Here's... Okay, there we go. Just needed to throw a link into the Discord. By the way, if for any of you who aren't aware, there is a Subcontrabassoon Discord now. Okay, so this is the overall the full assembly Subcontrabassoon CAD model. But right now, large portions of it are hidden. I'll go ahead and show those real quick. Okay. So, actually, now at one point, this was a pretty concise and logical file. But as I've made adjustments and modifications and revisions, as I've actually been working on the prototype, gradually it's gotten a little out of hand. So, you know, we have two different bells, and the structure of these files isn't consistent. So now that I have it on my home computer and don't have to go all the way to the shop, I've been going through and modifying these to get everything nice and logical again. So let's hide. So I've been going through in order. if anyone can actually hear me, can you post something in chat? I suppose I should have checked that first. Okay. Yeah. Okay, so here we have the these are the parts of the assembly that I've already worked on, that I've already gotten updated. So the top and bottom frame, the end pin, and this central support column. There were quite a bit of revisions here, but let's go ahead and open this subassembly here, the top frame. We can take a little bit of a closer look. I did make one change here. So if we go into this subassembly, this is the subassembly for the top frame, all the pieces that are eventually soldered or welded together. So I did have some changes I made here, just with the way these studs weld up here. I think this will make it a little bit. There we go. Should make it a little bit easier to see these edges. I also made a change here on the version I have behind me. I'll open up one of these tenons. On the version I had behind me, I had a thickness of 1.25 millimeters. But going forward, if I'm ever lucky enough to make a second subcontrabassoon, I'm going to make these slightly thicker. So thicken that out to 2 millimeters. And then all of those, likewise, 2 millimeters. But yeah, that subassembly is pretty straightforward. It's a pain to weld, but the actual geometry isn't that complex. I also did away with. Originally, I had all of these tenons had holes in them, but with the column, I began to feel like those probably weren't necessary, and so I got rid of most of those, with the exception of this tenon here. And the reason I kept them here is because this is the tenon for the tube assembly, and the tube assembly is not going to be supported by the bottom frame, only by the top frame. So I figured these retention screws would still be useful here. All right. So yeah, we can see these tube assembly retention screws. Let me really. And so we have, so what I've done is I have two versions of this top frame. One is an actual assembly that has all of the subcomponents. So each of these studs is separate. Each of these tenons that has to be individually machined are separate. And then I also have a soldered assembly. So this is just a separate version of the subassembly that I've gone through, and I've made all these aesthetic welds. Actually, I missed one here. So can do that real quick. Let's see. Yeah. So I'm just going to, I missed this corner there. And I don't really need this, but these soldered assemblies are what I end up using for the glamour shots, like on the website. Okay. So yeah, there's the top frame. Most of the changes are pretty small. Now, we can open up the bottom frame. I made the same changes. So I thickened these tenons to 2 millimeters instead of 1.5. I got rid of the retention screws, and I also changed the end pin sleeve to match the way that I actually ended up making it. And then, like the top frame, I also have a soldered assembly for renders and other things like that. I also changed, well, I'll talk about that in a little bit. So, and then if we go to the end pin, the end pin is actually quite a bit different. I originally had planned on using some custom threading for the end pin, but eventually I decided that it would be easier just to use readily available lead screw threads, and then just machine that. And then the slightly different design of the end pin stopper that I ended up using that matches the ones that I was able to buy. These are just 10 millimeter upright base end pin stoppers. So got all that done. And then the biggest change here was I completely redid the column assembly. So by adding a turnbuckle here, I'm able to adjust the length of the column without adjusting the angle of those top plates. So this allows me to not only I can use the column to gently push it apart, but I can also use it to gently pull it together. So overall, I think I'm pretty happy with this construction here. By the way, if anyone has any questions, feel free to ask. I can't imagine I don't exactly have a outline of what all I'm going to cover. Okay, so that's what I've done so far, getting everything up to date. So let's open up a new part. Let's start with this part here. This is the smallest body bend. And it looks like that. And so there's a couple of things that are kind of out of date here. So you see I still have these seams here from when I was planning on making it like this. out of a solid piece of plastic in 2 halves, and then sandwiching those 2 halves together, similar to how the top bend on a contrabassoon is made. And I want to keep those files. I don't want to delete them. Just in case I change my mind. But I do want to move them into a separate folder so that they're easier to hide. Now, one thing I've been doing is updating all the materials. There's some out-of-date stuff here. So let's change. There we go. So I've changed it, the material itself, to brass, which means for any sort of weight calculations, it's going to be brass. And then if I were actually making this, I would probably want to silver or nickel plate it. So I've added an appearance of silver just to make it pretty. And, well, I'm not going to mess with that. I thought about adding a slight fillet on all of these edges for rendering purposes, but I don't think that'll be useful. Okay. So let's create a hold on a second. So this is going to be here. So I'm going to create a new folder, and I'll just call that folder wood. So this is the construction I would need to use if I were making this bend out of wood. And in that folder, I'm going to add, here, let's hide all of these. Hide that, and hide that for the time being. So anything that I'm only going to need if we're making it out of wood, I'm going to put in this folder. So both of these, the seams, and all of these guard screws. So now I can hide and unhide this whole folder at once easily. Let me make that material change to the to here. So Jared, how would you make the metal Jared is asking how I would make the metal bogard custom form ? What do you mean by bogard? Are you talking about these seams? Or what I'm looking at right now, the pieces that hold the 2 halves of the bend together. So the way that I was probably going to have to do these is almost like a little roller. You take a flat piece of metal and then you roll it through a form. I've seen what they use at the Fox factory to do this. And I wish I had a picture of it to describe it, but it's this bizarre looking roller. And I would have needed different or multiple ones. So not doing that. If I don't need to make these pieces out of wood, then that will save me some custom tooling. And I should say that I've 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 come close to deciding that making that the bins. I really feel like 3D printed ABS is just the way to go. Even if I were making the rest of the instrument out of wood, I would be very tempted to use plastic for these bins, just because it drastically simplifies construction. It lowers the weight. It allows you to do any profile you would want. Now, for reasons I've talked about in other videos, these are actually cylindrical bins. But if I were to decide that I wanted these bins to be conical, by 3D printing them out of ABS, I could do that easily. And as I've talked about in an earlier video, acoustically, it's not even acoustically. There's good reason to believe that cylindrical bins would be just as good, if not better, than conical bins, which is what you might expect you would want. Okay. So these are, well, hold on. Let me open this and make sure. Okay, yeah, that's fine. Don't need to get too complicated with these little tiny screws. So let's hide all of those and get the updated version. The version that I'm actually going to be, or the version that I've actually made and think is the best option. Delete that. Okay, so let's start here. This is the frame assembly. So the only change I'm going to make here okay, yeah. So for so the thing I'm trying to fix here is I want this part isn't soldered to anything, so I don't need to make a separate subassembly. But I also have, for instance, this fillet that I have here is just cosmetic for the renders, as is this this little chamfer here. Trying to figure out if I should make 2 copies of this or yeah. Okay, I'll keep the 1 copy, and then if I need to export the, because like the way it is now, I can't export this face as a DXF because then it would be slightly undersized. So instead, what I can, but I don't need a whole separate file for that. I can just, since these are at the end, I can just move my end of part up, export the face then, and then move the end of the part. So that'll be fine. So Seltzer asks, how would you finish the bins in a way that satisfies traditionalists? I tend to be of the opinion that if it's plastic, I'd rather it look like plastic. I'd rather it, you know, not pretend to be something else. So, I mean, you know, the inner bore of a bassoon wing joint and half the boot joint is not wood. It's lined with either rubber or plastic. So I don't think, and even on the contrabassoon, most of the bins are made out of metal rather than wood. So I wouldn't think it would be that big of a deal. If someone was that concerned about it, I would suggest that, they just make it out of wood. Rather than trying to make the wood look like plastic. Okay. Now we have all of these frame nuts. Those are fine. And let's go ahead and open this. So these are this is the modified version of that bend that I've designed for 3D printing. So I have these the pilot holes for those screws already modeled into the piece. I've divided it into 4 segments to be glued together with ABS glue. Now, one thing I am going to change. Right now, I have the material set to Delrin, which isn't going to cause a problem, but if I wanted accurate weight, it would overestimate the weight by quite a bit if I had it set as Delrin. But I mean, it's not going to give me an accurate weight for 3D printed parts anyway, because the 3D printed parts are hollow. Austin says hi. Hi, Austin. Okay, so let's clear all of that. So wait, why do I have 5 bodies? Okay, I don't. All right. So let's just change that to smooth black to more accurately reflect the material. And of course, once I export this to Blender, I can, assign any value to this I want. Okay. So yeah, let's rename this. So right now I have a prefix of print added to all of these. Since this is going to be the main way that I'm planning on doing this, I'm going to change that to, let's just say body bin 0A R1, so revision 1. And I'm not going to probably what I'd like to do is make a separate copy of this that's not divided for rendering purposes. Okay, so I'm going to change the name of this one as well. So the easiest way I know how to do that on Inventor is save and replace. Okay, and I'm going to body bin OR1 and save and replace this. And I'll make a glued version of this. And then I can just undo all of... I can delete all of these splits. And what are all of these delete faces for? Delete those. Delete all those pin. So these are, well, here. So if we go back to the version that's been split up, you can see here I have the holes for alignment pins. This is just 1.75 millimeter nylon filament that I've used here to get these pieces in alignment, but I don't need them for the glued model. So I can delete those, delete those. Yeah, that's fine. Don't need any of those. I do want those. Okay. There we go. Select all. Smooth black. Okay. So now I have a... I actually ended up with 3 versions of the body. So the construction version, which has the 4 separate components, the wood version that has the 2 halves, and then the single version. And I'm just going to align this other version. Just put, since the glued version is a copy of the construction version, I'm just going to add constrain it to all of the origin axes. And then that will get it exactly where it needs to be. Okay. What progress, Seltzer asks, what progress I've made on the Subcontrabassoon read. Well, I haven't made a lot of progress, or I haven't been messing with the reads too much, but I did make a shaper. If you look at one of my recent live streams, there's a stream called Shaping a Shaper onto Shape Oko, where I talk about where I go over the process of how I made a shaper, including a Subcontrabassoon shaper. So that will make experimenting with reeds much easier when that eventually happens. I don't need this. Okay. So all of that, and then okay. So I think that does it for this part here. And I can go ahead and make that visible here. And then go in and hide the wood stuff. And wait, that wasn't right. All right, there we go. So all right, actually, here, before I move on to something else, let's open up one of these and take a look at the construction here of this body joint. So this was these bins are actually quite simple. I've taken a cross section here with a given radius, a given inner diameter, and a given wall thickness. And all of those are calculated from the master spreadsheet. Well, here. If I go into my parameters, so this section here, these are parameters that have been imported from the master spreadsheet. So hole position F1, pad size F1. The original thought was that this would make it easier to make changes by just changing a spreadsheet. In actual practice, I shouldn't have used this many or this much of a spreadsheet, because now if I do want to change one of these variables and update the spreadsheet, it literally takes like 10 minutes for the entire model to update. So the position in the model parameter uses, or the user parameter of position refers to the spreadsheet parameter of bin to C00, which if I go down here, it's just the position in the bore at which this bin starts. So 3082. So instead of just entering 24.892, what I've done is I've just said I'm multiplying the position times the taper, which will produce the diameter at that point. And then the wall thickness is also a parameter, as is the radius. And then that is revolved around this central axis, 180 degrees. So I could do 90 degrees for a quarter bend. I could do 360 for a donut, but I need a 180 degree bend. And then these are just work axes for constraining the part. Then I've split it in half. And then I've cut off a little bit from the end to make up for two things: to make up for the thickness of the plate that it's bolted onto, and also to compensate a little bit for the acoustics of having such a small or having such a tight bend. So let's go back here. So that's how the geometry of these bins are. Austin, I think you were asking what this is. This is the top bend, or the top the frame assembly that kind of holds the entire subcontrabassoon together. And then there's another frame assembly on the bottom. So when you have a bend, the tighter it is, and by tight I mean the larger the bore diameter relative to the bend diameter, the less, or the more that bend deviates from how it would sound if it were a straight piece of the same length. If you have a big sweeping bend, like the type that you're going to see on a lot of like brass instruments, the difference is negligible. But on some of these very tight bends that we like to use on woodwinds to make things practical, there can be deviations. Specifically, it can interfere with the tuning in different octaves or different registers. So this one isn't that severe, this bend here, but it will still, ideally, in order to sorry, trying to think through this while talking. It needs to be shortened a little bit to work the way, or to function with the length that it needs to. Okay, so what's going on here? Update. Okay, now everything's relationship with undefined geometry. Okay. Okay, yeah, I know what that is. So all of these frame nuts were constrained to these holes before I chamfered them. So then when I when I chamfered the holes, it threw an error. So instead of doing an insert constraint, which is essentially constraining that circle to this circle, that's what I did before. But as a consequence, if I get rid of that chamfer, the constraint breaks. So instead, what I'm going to do is two constraints. First, I'm going to do a mate constraint there. So surface to surface. Okay. So now the frame nuts are constrained to be flat with the surface, but not with the hole. And now I'm going to add a center line, mate the center lines to one another. So the end result will be the same, but now if I get rid of those chamfers for some reason, it won't break. Okay, there we go. Oh, amazing sound effects. Yeah, that's when you work with Inventor, you actually it becomes a very reassuring sound effect, that nice little pop when a constraint goes through, because the other possibility is that the constraint that you try to add conflicts with a constraint, and then you get the evil bong, like boom. Here, I can do that. So if I just constrain, there we go. Yeah, that's the sound you don't want. That means you tried to do something illegal. Okay. So that should be it there. So while I'm here, before I go through and update the rest of these bins, let's take a look at a different part. So this is the wing assembly. So these are the three body joints that make up the Subcontrabassoon wing section, with tone holes for F sharp, F, E, E flat, D, and C sharp on the back. So I'm just gonna open up more of these. Hold on. So here we have the first body joint in a subassembly, and then open up that subassembly, and you finally get to the body joint itself. So much in the same way we talked a little bit about the construction of the bins, I'll go ahead and open up this so you can see how this is constructed. I'll move the end of part all the way to the beginning. So this is how it starts. Actually, hold on a second. So this is the part that I have on screen right now. You can see that just like the part on screen, I just have the outer profile. I haven't done any tone holes yet. But this was actually, I tried something interesting here. Instead of 3D printing this, or instead of machining it out of a solid rod, I 3D printed 3D printed this solid. So instead of, with a couple shells and then hollow in the middle, this was printed with completely solid 100% infill, and then glued together, and then I put that on the lathe and machined it just like any other piece of material. The big advantage being, instead of having to hog out all of that material, it was only slightly undersized for the reamer. So that ended up saving a lot of trouble, and it's also much lighter than Delrin. ABS is about I think 1.05 grams per cubic centimeter, whereas Delrin's more like 1.5. So 1.05 versus 1.5. So this is even 100% solid. This is significantly lighter than Delrin. A little bit heavier than it would be if I made it out of maple, but lighter than Delrin. Okay. Nope, wrong one. You don't need to see that much of my face. There you go. That's better. Okay. So once again, this is a revolution of a sketch of a cross section around an axis. So if I open up this sketch, you can see that I just have the basic cone. So here we have the calculation of it's calculating the overall length based on some parameters I've set in the spreadsheet. Likewise, here is data it's pulling from a spreadsheet. More data from the spreadsheet. So all of this is constructed from the spreadsheet. So if I'm willing to wait 5 minutes for the spreadsheet to update everything, that theoretically makes it easier to update. So for example, here we just have the position, which is the position along the bore where this body segment begins, times the taper, divided by 2, because this is the half of the profile. And then we have the tenons and the little indentations for string. Then we edit. So, and this is just another rotation about a central axis. 360 degrees. So, and this The next part I definitely could have done more easily. So there's all of these work planes and work axes, and all of that is for positioning these holes, as well as giving myself all of the, well, here, I'll show you what I mean. Okay. So these are the holes themselves. And then if we go down here, we have the hole facings. Okay. So all of those work axes that I defined up here, these work planes and work axes, allow me to get a sketch plane where I need it here. So this is where I'm defining the facing of the tone hole. So actually, let's not do that. There we go. So on a woodwind, unless you're playing it with your fingers, if it needs to be closed by a pad, of course you don't want just a plain hole. You want a facing for the pad to set on, and that's what I've done here. Seltzer asks, why did I use a thread fit instead of cork? Because it's more flexible, more room to adjust for things that go wrong. With cork, you could end up having to do a lot of sanding. I just felt like thread was the better solution for this particular design. Also, you know, if I end up putting it together and then some of the body joints are loose, I can just add a little more thread, not have to completely tear off the cork and replace it with thicker cork and then sand that cork. Yeah. Thread is, I'm not suggesting that thread is necessarily better. It was just better here. Okay, now all of these here are working to define the posts, the post locations. So if I go down here, we have a post there with threads. So it gets, because everything's at a slight angle, it does actually end up getting fairly complicated in order to position all of these post holes. Not only positioning them, but for example, some of these post holes are only required on certain modifications. So like for example here, you see there are 3 half-hole vents instead of 1. That's because I'm planning for the possibility that I might need 2 half-hole vents in which case it would be this vent and this vent would be the ones I use, instead of the single vent that I'm planning on, which means that I need to have a plan for all of these post holes up and down, or all these post holes that may not even appear on the finished version. Okay. Soupman says good afternoon. Good afternoon, Soupman. Okay, so I can close that. And then in the subassembly, I've just added the components that only involve this single body joint. So all of the posts, this tone hole riser here, the string, and this cradle here. And we can see here I've suppressed some of those features at some point in order to because I cut these out on the Shapeoko, so I needed a format, or I needed to export this face without these chamfers. So that's why all of that was done. Here, I'll go ahead and update this while I'm at it. I did end up making those out of brass instead of nickel silver, just because I had some extra brass and didn't think it would do any or make any difference whatsoever whether I made those out of brass or nickel silver. Means it looks slightly less pretty because you don't get that contrast between the silver cradle and the brass screw, but whatever, it's fine. Now these posts, I am going to have to go through and change some things. If I sketch. So one issue I ran into, let's see if I can find this. Save. Okay, here we go. So when I originally started the design, I kind of made an assumption that the 5mm posts were actually going to be 5mm, and the 7mm posts were actually going to be 7mm. Unfortunately, when I ordered these posts and got them in, I discovered that they weren't. So here in red is what I expected the post to measure based on the dimensions I got from the company, but the yellow is the actual measurements. So I am going to have to go through and modify those posts. Now, instead of adjusting the... Instead of changing every key, because if I change the height of these posts, that affects the height of every key. What I'm going to do is just change the depth of this counterbore here to adjust for the discrepancy. Luckily, the post that I use the most often, the 7mm post, were quite accurate, only about 0.2mm discrepancy, and this post here with the largest discrepancy, over 1mm off, I only used it at one point on the top bend and I ended up making adjustments there anyway. So it's not going to be that big of a deal, but it is something I'm going to go ahead and fix now, or not on this stream, but soon. Okay, anything else worth talking about here? I think that's okay. And then once we get the entire section together, that's when I added key work. So if I open up here, we can see a key subassembly. And right now there's a bit of a mess between some key work has an aesthetic chamfer, some doesn't. You see there's a whole bunch of... Okay, I see. Hold on a second. Okay, yeah. So here we have a key assembly. Right now they have some modifications that I made for cutting them out on the Shapeoko, like stamping the name in there. There's the name or the label of the key isn't going to be stamped on there on the finished version. I just needed this here. So when I was having to export the SVGs for nesting purposes, it's really it's a little bit convoluted, but this is why I'm looking forward in going through and fixing all of this up. And actually, you all might find that interesting. So, well, I think I'll have to talk about that later. So I'm trying to think if anyone has a question on how some part of the Subcontrabassoon is built in CAD, now would be a good time. And I'll either answer now or make a note to answer that in a future stream. Oh, I wonder if this has completely broke. Let's see. I was actually kind of proud of this. If I remember correctly, or at one point, I actually had this set up so that, here, I need key assembly 04A. Okay. So, if nothing has broken, if I change this so the key is depressed, that spring should automatically bend to shape. Ha! And then, completely unnecessary, but it made me happy. The Aquarian Space asked why Autodesk Inventor. Autodesk Inventor is the program I learned to use when I was working for my dad full-time. It's the program he uses. So that's what I learned to do. I've since worked a little bit with Fusion. And it does do most of the stuff Inventor does. I'm more comfortable with Inventor, and it does some things that I haven't been able to get Fusion 360 to do, like taking a straight piece and then bending it rather than having to loft along a rail, which isn't really applicable to the Subcontrabassoon. but it is something I've used on some of my contrabassoon bells. And unfortunately, I have not, to the best of my knowledge, there is not a true Fusion 360 is the closest thing to a free 3D CAD program I've found. Inventor, I got lucky. I was able to install it on my home computer because they have an education program that allows you to download and use if you meet certain requirements. And for the longest time, I just assumed that being an adjunct bassoon instructor at a tiny university in Cherokee Nation wouldn't qualify me to be able to download Autodesk Inventor, but apparently it did, so I'm okay with that. But not everyone is going to have or be able to do that. So Fusion 360 is a reasonably good alternative, but it's also not very... I haven't really tried moving things from Inventor to 360 and back yet, but it doesn't look especially fun. I think you might have to like export it as a step file, and since all of these files were already in Inventor, it makes things so much easier to just keep it with Inventor. Okay. Trying to think if there's anything that you all haven't gotten to see yet. So here's the tube assembly. One of the more complicated parts. Once again, subassembly within subassembly within subassembly. So each key is its own subassembly, and some of those keys have modifications. Here I have something that's a little bit broken right now. So this key arm is supposed to be at an angle, at a 90-degree angle. But in order to cut out the part on the Shapeoko, I flattened it. So now it's kind of sticking up at an awkward angle. And so still a lot of work to do to get everything updated to where I'd like it. And this isn't my top priority right now. My top priority is getting the prototype itself, but keeping all of the documentation in line will make things easier in the long run, I feel. All right, so probably, unless anyone has another question, I'm probably gonna finish up here soon. I'll go ahead and open here. So this is the wing bend, the second smallest. So go ahead and open these, update the materials. can we get a close-up of the current prototype? What do you mean by close-up? So the best, I mean, I'm happy to show you all a close-up at the CAD model, but if you want the best view, if you're on a desktop computer or you're on Wi-Fi, the best option would be actually going to the Subcontrabassoon website, and you can look at these renders freely. Oh, the one behind. Yes. Yeah. I'll bring that a little bit closer soon. But in case anyone didn't know, you can go to the website and find renders. So this is before what I was talking about the glamour shots. So how some of these, I have two versions of the file, one for construction and one for appearance. So if we go into the frame assembly, how, you know, these have welds and all that kind of stuff. Okay. Let me get this updated real quick. So silver, where's, why is silver not an option? That's interesting. There we go. Zeno Tesla asks about the guan. The name does sound familiar, but I couldn't. I wouldn't guarantee that I could pick it out of a lineup. It's one of those things I have heard of, but not enough to really know a lot about. All right, so go ahead and put this chamfer on, or sorry, the fillet. If I wanted the metalwork to be a different, the Aquarian space is saying if I wanted the metalwork to be a different color, that would be possible. Like, do you mean in the software? Yeah, absolutely. If you're talking about like getting it parts of the actual prototype specially plated, like, I don't know, green chrome or something, probably also possible, but much less likely. Okay, let's see. People wanted to... No. Sorry, I keep on forgetting these. Okay. All right, so I'll bring the prototype a little bit closer. I'm not sure I'm going to be able to get the whole thing in frame at once because I don't have a camera person, but we'll see what we can do. You know, the thing is big enough, I think you're actually going to get a better view of it back in the stand. But you can see some of these bell support assemblies that I added not too long ago. This is that central, the column with the turnbuckle I was talking about. So if I loosen those screws at the bottom, I can turn this and it will adjust the length of the column to aid in assembly. Way up here, which so here we have this top frame assembly, welded together out of several pieces, and these bins that I was talking about, these are each of these bins is made in 4 segments glued together with ABS glue, which is pretty close to chemically welding them together with acetone. And then way down here, sorry, you're going to see quite a bit of the mess. You can see the bottom frame and the end pin assembly. And I'm pleased to report the end pin feels very sturdy. The only thing that I'm not quite happy with so far is this column, the central support column. It feels very sturdy holding it like this, but if the instrument's lying down, if you try to pick it up from the central support column, it feels a little bit insecure. So there's a couple things that I might do to address that. I do think I should look into getting a closer tolerance tap for this turnbuckle. I also, and actually I didn't talk about it, but I already have modified the hold on, let me test. Okay, I already have modified the CAD model, so I'm making this turnbuckle a little bit longer. I'm making longer threads through all of this. So I'm making this threaded nut that's welded inside of the column slightly longer. The thread is longer, so there's more engagement, or more thread engagement. But it's also, I think, just going to be one of those things that I might just need to tell people, hey, don't pick it up out of the case from the central support column. Well, okay. Luckily, those don't really do anything. These are just to cover up, those nuts are just to cover up these threads. They don't really hold anything in place since these plates are threaded. Trying to think if there's anything else here. Oh! I need to just remove this ceiling fan. This is going to cause problems sooner or later. Okay. So, I did make a decision that I'm going to, since this body joint also has doesn't have much key work at all, I 3D printed this as well. This is the body joint with the A-flat tone hole. I still need to go in and I oversized this tenon a little bit so that I can turn it down to size so I get the exact fit I want. So right now it's a little too snug to go in there completely. But this is the first joint. So this is what's going to have the half hole vent, the open F tone hole, and the E to F sharp trill key tone hole. Okay. And Unfortunately, the actual physical progress that's visible here isn't that much. So behind the scenes there are. So I've been working on making the reamers. I have made the reamers for the three smallest body joints. I've gotten one of them reamed out. So this is the finished bore on this one. Let's see if we can. Okay, I'm going to go ahead and put this back in the stand and try not to slam it into the ceiling fan. I almost need a camera on this so that I can see the in-pin stopper. Okay. There we go. Okay. So, Bluesman1 asks, is the case modeled in CAD at all, or is it something you plan on have made by hand? I have not messed with the case whatsoever yet. Oh, don't do that. There we go. Yeah, the case is one of those things that is gonna. I figure I'll worry about that when the instrument itself is ready, kind of like a car, because a case for this instrument would not fit in my current car. So I'm gonna have to figure that out as well. Maybe I can just combine them and make a case that has a, or make a car that has a built-in Subcontrabassoon case. Okay. So I think that's all the questions. I know it's been a little bit sparse lately, but I want you all to know progress is still going. Maybe not as fast as I'd ideally like, but it's going nonetheless. If you have any questions that I didn't answer in this stream regarding the CAD or the construction, feel free to leave those in the comments below, and I'll read them and think about if there's enough questions that I didn't answer here. Looking into it for the for another CAD. I know one topic I would like to actually do regards modeling of some of the key work. So, and I'm not going to be able to do that today, but for example, excuse me, sorry. Let's open that. So for example, so let's take this linkage here. This is the linkage between the the low F key and the F to F sharp linkage. So let's so how did I make it so that these are the right length, and it's a little bit finicky, but the method I came up with works pretty well. So for example, here I have when the link or When the linkage is in the closed position, everything lines up perfectly. And then when it's in the open position, it also lines up. There is if you look very closely, hold on. If you look very closely, you might see that there's a little bit of an overlap here as the metal overlaps into the cork, but that was actually on purpose. I included a cork compression factor, assuming that, it would indent into the cork very slightly. Now, of course, at this scale, it's all so small as to be it's really going to come down to like manufacturing tolerances and hand filing to get everything those last few tenths of a millimeter. So the process I'm talking about is to get it close enough so that works. Okay. Well, I think that's going to be it. Thank you all for dropping by. I know this isn't the most exciting thing, but hey, we live in a world where thousands of people are watching YouTube to watch other people kill each other on Among Us. So there's got to be at least like 4 people that want to watch something like this. Hope to see you all soon, and feel free, once again I encourage you to, if you're on Discord at all, check out the Subcontrabassoon Discord. While I'm thinking of it, let me put a link in the channel description, or in the description of this video. No, that's not what I want. There we go. Okay. Well, thanks again, and see you all later.